In this video, I'm going to show you what quadratic equations are and what their standard equations look like. And then we're going to use this knowledge in order to sketch those standard equations. So first, what are quadratic equations? Well, quadratic equations are equations with a degree of 2. And what that means is when you look at your equation, you have to find the x term with the highest exponent, and if that exponent is 2, then you're dealing with quadratic equations. So that's the degree of the equation. Now, for example, if you would have a equation with a x term with the highest degree of 3, then that equation would have a degree of 3. So when the degree is 2, then you're dealing with a quadratic equation. And there are 5 standard equations for quadratic equations, which are listed down here. I'm going to cover them each one by one. So we're going to deal with the circle, which obviously looks like a circle, the parabola, which can be either up or down, the ellipse, and then we have two types of hyperbola. One which looks like this and the other one which looks like that. Let's first start by looking at the circle equation. Well, the standard equation for a circle is x minus h squared plus y minus k squared is equal to r squared, with r the radius of the circle and h, k the x and y coordinate of the center of the circle. So let's apply this equation for these two exercises. Well, we have that 2x squared plus 2y squared is equal to 32. So the first thing you have to notice is that this equation right here and the standard equation have some similarities but are not in the same form. So we still have to do some type of operations to get it in the standard form. So let's do this by dividing by 2 to both sides. So then if we have 2x squared plus 2y squared is equal to 32 and we divide both sides by 2, we'll get that x squared plus y squared is equal to 16. And now if we want this equation in the exact form as the standard equation, we have to set h and k equal to 0. So we'll get x minus 0 squared plus y minus 0 squared is equal to 16, which is the same as 4 squared. So now we know that the center point according to our standard formula will be the origin 0, 0, and that the radius will be 4. So if you wanted to sketch this, it will look something like this. So here is our x and y axis. The center of the circle is just the origin, and then we'll have a radius of 4. So just go 4 up and 4 to the side for each of the axes, and then you'll draw a circle like this. So this right here will be 4, 4, -4, and -4. So this is a sketch of the first exercise. For the second exercise, we have 4 times x minus 1 squared plus 4 times y plus 2 squared is equal to 64. Well, again, you see a lot of similarities between this equation and the general equation. So let's do some operations to get it to the standard form. So divide both sides by 4, and then we'll get x minus 1 squared plus y plus 2 squared is equal to 16, because 64 is the same as 4 times 16 over 4, and the 4 will cancel, so we're left with 16. And 16 is the same as 4 squared, so now we have written the equation in standard form. And now we can read off that the center point is equal to 1, -2. The reason why it's -2 is because in the standard equation form it's -k, and in our equation it's +2. So in order to get this negative sign to be positive, k has to be negative, because negative times negative is something positive. So that's why it's negative 2. Now the radius is just 4, so if you wanted to sketch this, it will look something like this. First, let's draw our x and y axis, and the center point is 1, negative 2. So if this is 1, then this is negative 2. So right here is our center point, and now we're just going to have to move 4 steps in the vertical and horizontal direction in order to get our circle. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So it will look something like this. So next we're going to take a look at the general equation for a parabola, which states that y is equal to ax squared plus bx plus c. So a parabola has two forms. One form which is called a convex parabola, and this occurs when the a coefficient in front of the x squared term is positive. And the other form is what is called a concave parabola, and will look something like this. So this occurs when the a coefficient is in fact negative. And one way I like to remember that is by imagining a smiley face like this. So a smiley face is positive, so therefore the a term must be positive. And for the concave term, and for the concave form, we have a sad face, and a sad face is always negative, so the a term must therefore be negative. Now, there's one other thing you need to know in order to sketch parabolas, and that is what the coordinates are of the lowest and highest point of the parabola. So the formula is for both points the same, and it is negative b over 2a for the x coordinate, and for the y coordinate we just fill in the x coordinate into the function. So it's denoted by f with negative b over 2a filled in for x as our y coordinate. So the function that we are talking about is this one right here. So we can write down that f of x is equal to y is equal to ax squared plus bx plus c. So that's everything you need to know about the theory behind the general equation for parabolas. So now let's apply this in some exercises. Now for our third exercise, we have that y is equal to negative x squared plus 2. So if you look at our general equation, we already can see that our a coefficient will be equal to negative 1, and our b coefficient will be equal to 0, because we don't have a x term in our specific equation. So if this isn't obvious for you, you just can imagine a plus 0x in our equation, which doesn't change anything about our equation, but just let us know that our b coefficient is in fact 0. So because our a coefficient is equal to a negative number, so a is negative, means that we're going to deal with a concave parabola. Remember the sad face? So the only thing that is left to do for us is just to calculate the highest point of that parabola, which is denoted by our formula negative b over 2a for our x coordinate, and negative b over 2a filled in our function. So let's calculate what negative b over 2a is equal to. So negative b over 2a is equal to negative times b, so b is 0, and 2 times a, which is negative 1, so it will become negative 2. So this just will become 0, so our x coordinate will be 0. And for our y coordinate, we just have to fill in our x coordinate in our function. So our function is negative x squared plus 2, so if we fill in 0 in our function, we will get negative 0 squared plus 2. This will become 0, and we're just left with 2 for our y coordinate. So the highest point of our parabola will be 0 for our x coordinate and 2 for our y coordinate. So let's try to sketch this. Let's first start off by drawing our y-axis like this, and then our x-axis. So the point 0.2 will be right over here, so 0.2, and we know that our parabola will be concave, so it will look something like this. Now, if you want to be very accurate with your sketch, you can also find the intersection of the graph with the x-axis. So the only thing you need to do to find out what the intersection with the x-axis is just to set y equal to 0 in our function. So y is equal to negative x squared plus 2. So if y is equal to 0, we have 0 is equal to negative x squared plus 2. If we add x squared to both sides, we will end up with x squared is equal to 2. So now, if we square both sides, we get that x is equal to positive or negative the square root of 2. So this will be our intersections with the x-axis. So this will be negative the square root of 2, and this will be positive the square root of 2 for our x coordinates. And this will be our sketch for our parabola, like this. For our fourth exercise, we have that y is equal to 2x squared plus 3x plus 1. So if we compare this with our general equation, we can see that the a coefficient must be 2, the b coefficient is equal to 3, and c is equal to 1. So because our a coefficient is positive, we will deal with a convex parabola. Remember the smiley face. So now the only thing we need to do is to find the lowest point of that parabola, which is denoted by our formula negative b over 2a for our x coordinate and negative b over 2a filled in our function for our y coordinates. So let's calculate what our x coordinate is equal to. Well, negative times b, and b is 3, over 2 times a is 2 times 2, which is 4. So negative 3 over 4 will be our x coordinate. But now we have to fill in negative 3 over 4 in our function in order to get the y coordinate. So let's do that. Well, f of x is equal to 2x squared plus 3x plus 1. So if we fill in negative 3 over 4 in our function, we will get that this is equal to 2 times negative 3 over 4 squared plus 3 times negative 3 over 4 plus 1. And now we'll just have to compute this. So we'll get that this is equal to 2 times negative 3 squared is just positive 9 over 4 squared, which is the same as 16, plus 3 times negative 3 is equal to negative 9 over 4 plus 1. So we'll get that 2 times 9 is 18 over 16 minus 9 over 4 plus 1. So now we have to find a common denominator. So let's take 16 as our common denominator. So we'll get 18 over 16. And now we'll have to write down negative 9 over 4 as something over 16. So note that if we multiply negative 9 over 4 by 4 over 4, which is the same as multiplying by 1, we will get that negative 9 over 4 is the same as negative 36 over 16. So now we got our denominator of 16. And now we have to set 1 equal to something over 16. Well, if you multiply 1 by 16 over 16, we will get that 1 can be written as 16 over 16. So now we'll have to add everything up. Well, 18 plus 16 is equal to, well, 10 plus 10 is 20, and 8 plus 6 is 14. So 14 plus 20 is 34 over 16, and we will rewrite 36 over 16. So now 34 over 16 minus 36 over 16 will be negative 2 over 16. And we know that 16 can be rewritten as 2 times 8, so the 2's will cancel out and we are left with negative 1 over 8 for our y coordinate. So now the lowest point of our parabola will be negative 3 over 4 for our x coordinate and negative 1 over 8 for our y coordinate. So if we wanted to sketch this, we can draw a y-axis like this and a x-axis like this. So the point negative 3 over 4 will be, for example, around here, negative 3 over 4, and the point negative 1 over 8, well, that will be something over here. Let's call this negative 1 over 8. So our lowest point will be this right here, and now we're just going to have to draw a convex parabola like this. So this is our solution. Well, for our last exercise we calculated the intersection with the x-axis, so now let's calculate the intersection with the y-axis. So we can do that by setting x in our function equal to 0 in order to get our intersection with the y-axis. So if our function y is equal to 2x squared plus 3x plus 1, well, if we set x equal to 0, this will become 0 and this will become 0. So our y intersection will be y is equal to 1. So this right here, where it intersects, will be equal to 1. And this will be a good enough sketch for our parabola. Next, we have the ellipse, which states that when we have an equation that looks like x minus h squared over a squared plus y minus k squared over b squared is equal to 1, then we're dealing with ellipses. And once again, the point h, k will be the center of the ellipse, and a ellipse will look something like this right here, of this right here. So the center point will be right over here and right over here. So in both these cases, the center point is just the origin, so h and k will be 0, but this is just an example of an ellipse. Next, we have the constants a and b, and those constants will tell you how far away the ellipse is from the center point. And the a constant will tell you how far away the ellipse is parallel to the x-axis because it's underneath the x, and the b constant will tell you how far away the ellipse is parallel to the y-axis, as you can see right over here. So a will be this distance, so the distance between the ellipse right here and the center point, and because a is underneath the x, it will be parallel to the x, and for the b constant, it's parallel to the y and will be the distance from the center point to the ellipse like this. And the same for this example, the a is this right here and the b is this distance. So now let's try to apply this for the following exercises. So for the first exercise, we have that x minus 2 squared over 9 plus y plus 2 squared over 4 is equal to 1. So the first thing you want to note is this is in fact the right form for an ellipse, because this equation and the general equation for an ellipse almost look alike. The only thing that is left to do is write down the 9 as something squared and the 4 as something squared. So let's do this. So x minus 2 squared over 9. Well, 9 is the same as 3 squared, and then we'll have y plus 2 squared over 4, and 4 is just 2 squared is equal to 1. So now this equation is the same as the general equation form for an ellipse. So now let's try to sketch this. So our center point is 2, negative 2. So if this is 2, then this will be negative 2 and our center point will be right over here. Now the distance parallel to the x-axis will be 3, so I'm going 3 to the right, 1, 2, 3. So this will be the end of the ellipse, and I'm going to the left, so 1, 2, 3. So this will be the end of the ellipse. And then for the b constant, which is parallel to the y-axis, I'm going to go 2 up, 1, 2 right here, and 2 down, 1, 2. So those 2 points will also give me the end of the ellipse. And now we just have to connect points. So it will look something like this. So this is going to be 2, this is going to be -2, and this is a good sketch for exercise 5. Next we have that x squared plus 4y squared is equal to 8y. Well, now you can't immediately tell that this will be an ellipse, but let me convince you that this is in fact an ellipse. Well, if we bring the 8y to the left hand side, so by subtracting 8y both sides, we'll get that x squared plus 4y squared minus 8y is equal to 0. And now we want to make sure that this part right here will be a perfect square. So this equation will look more like the general form of a ellipse equation. So we want to write down 4y squared minus 8y as a perfect square. So how do we do that? Well, so we want 4y squared minus 8y in the form a minus b squared. And we know that a minus b squared is the same as a squared minus 2ab plus b squared. So in this case, a squared will be this right here, and negative 2ab will be equal to negative 8y. So let's write this down. So a squared is the same as 4y squared, and 4 is the same as 2 squared. So if we take the square root of both sides, we'll get that a is equal to 2y. So let me write this down here. So a is equal to 2y. And next we have that negative 2ab is the same as negative 8y. So if you multiply by -1, the negative signs will cancel. And we know that a is equal to 2y, so let's fill that in. So 2 times 2 is 4. Then we get 4y times b is equal to 8y. If we divide both sides by y, the y's will cancel, and we'll get that 4b is equal to 8, or b is equal to 8 over 4, which is the same as 2. So now, if we want 4y squared minus 8y to be written down as a perfect square, we want that So now if you want that 4y squared minus 8y is a perfect square, we have to add a 4 term, because b is 2 and 2 squared is 4. Because according to our calculations, if we have 4y squared minus 8y plus b squared, with b is 2, so 2 squared is 4, we have that this is equal to a minus b squared, and we know that a is 2y, and we know that b is 2. So we have to add a 4. But if we want to do that without changing anything of the equation, we have to add 4 and then subtract 4, which is the same as adding 0 to an equation. So everything remains the same. So let's do that. So we'll get that x squared plus 4y squared minus 8y plus 4 negative 4 is equal to 0. So note that we didn't change anything because the 4's will cancel each other out. But now, if you look at this part, we know that this can be written as 2y minus 2 squared. And then we have the negative 4 is equal to 0. And if you aren't convinced that 2y minus 2 squared is equal to 4y squared minus 8y plus 4, well, 2y minus 2 squared is the same as 2y minus 2 times 2y minus 2. So if we distribute 2y times 2y, we will get 4y squared, and 2y times negative 2 will get us negative 4y. Then negative 2 times 2y will get us negative 4y, and negative 2 times negative 2 will give us plus 4. So we'll get 4y squared minus 8y plus 4, and this is in fact the same as this. So now let's get rid of the 4 by adding both sides with 4. So we'll get x squared plus 2y minus 2 squared is equal to 4. And now divide everything by 4, because according to our general equation, the right side has to be 1. So if we divide both sides by 4, we will get a 1. So we'll get x squared divided by 4 plus 2y minus 2 squared divided by 4 is equal to 1. And now there's one small thing we can do, and that is factor out the 2 right over here. So we have x squared over 4 plus 2 we can factor out, and will give us 2 times y minus 1 squared over 4 is equal to 1. And this will give us x squared over 4 plus 2 squared will give us 4 times y minus 1 over 4 is equal to 1. So the 4's will cancel. So now we have that x squared over 4 plus y minus 1 squared is equal to 1. And to write it down in the general form, we can write x squared as x minus 0 squared over 4, which is the same as 2 squared, plus y minus 1 squared over 1, which is the same as 1 squared is equal to 1. So now we have our general formula of an ellipse. And now let's sketch this. So let's start by drawing our y-axis and then our x-axis. So the center point will be 0, 1, and the distance parallel to the x-axis will be 2, because a is 2. So 1 step, 2 step to the right, and 1 step, 2 step to the left. So this will be the endpoints of the ellipse. And then for the distance parallel to the y-axis, b is just 1, so we only have to go one step up like this, and 1 step down like this. So our ellipse will look something like this. So this is the sketch of our ellipse. Next, we're going to take a look at the general equation of a hyperbola of the form x minus h squared over a squared minus y minus k squared over b squared is equal to 1. Well, this form will look something like this. And in order to sketch this in greater detail, we'll have to know how to draw a box. And to know where to draw this box in the xy plane, we'll have to know the center of the box. And the center of the box, so the center point of the box, is denoted by h, k. Those are the coordinates of the center point of the box. So h is the x coordinate and k is the y coordinate. So just imagine that right over here you have a point hk. So this right here will be h, and this right here will be k. Well, in order to draw a box, we'll need to know the length of the sides. So there are two coefficients that will tell us what those sides are. First, we have the a coefficient right over here, and because the a coefficient is underneath the x, it will tell us something more about the length of our box in the x direction. So this a will tell us the length in the x direction. So we'll have to go So we'll have to go a steps in the x direction, so 1, 2, and let's say that this is the a step, so let's say that a in this case is 3, and then we'll have to go a steps in the other direction, so 1, 2, a, and this will be the length of one side of our box. Next we have to find the length of the box in the y direction, and this will be given to us by the coefficient b. So let's say that b in this case is 2, so then we'll go one step in the y direction and b steps in the y direction like this, and just as before we'll have to go b steps in the opposite direction, so one step, b steps. So now we can draw our box as follows, like this. So now we're going to have to draw our asymptotes, and the way to find those asymptotes is simply by connecting the corners with each other. So we'll have to connect this corner with this corner, so the opposite corners, and this corner with this corner. And now just make our lines much bigger, like this. And now we have everything we need in order to sketch our hyperbola, because we know our hyperbola will be of the form this. So if we draw this according to our box, you see we have to follow our asymptote, but don't touch our asymptote, because that's the whole point of asymptotes. Then we'll hit the center of this box side and then just follow the asymptote as follows, like this. And then we'll repeat the process for the opposite side. So we follow the asymptote like this, we hit the center of the side, and we follow the asymptote back like this. So those two lines will be our sketch of our hyperbola. But now, what will be the equations of the straight lines? Well, in a previous video I teach you how you can set up equations for straight lines, and one equation was the y is equal to mx minus x1 plus y1 equation, which is the point slope equation, which basically tells you if you have the slope of the line and you have a random point that is on the line, then you can find the equation of the straight line. So do we know the slope? Well, the slope is the same as the change in y over the change in x, and the change in y, let me do it in another color, the change in y is basically this right here, which has a change of b, and the change in x, well, this is this length right here, which is just given by a. So the slope will be equal to b over a. And now we have to find a coordinate that satisfies this line. Well, we know that the center point is satisfied by both straight lines, so we can take that point in our equation, and we know that that point is given by h, k for our x and y coordinate. So we can say that the equation of our two asymptotes will be y is equal to b over a for our slope times, let me remove this, x minus x1, which in this case is our h, plus y1, which is in this case k. So this will be our equation for the straight line for our asymptote going upwards. Now we can do the same procedure in finding the equation for the asymptote going downwards. Well, so for the asymptote going downwards, we have that the slope, which is equal to the change in y over the change in x, will be equal to negative b over a, because now we're going in the opposite direction of b, so this will be negative b over 2a. Another way of looking at this is, in my previous video I said that the slope is equal to rise over run, which can be interpreted like this. We rise as follows and then we run. So then we'll get a line that is going upward. But if you have a line going downwards, you'll have that your slope is equal to negative rise over run. So now we go downwards and then we run. So now we'll get a straight line going downwards. So that's why the b must be negative, because we're dealing with a straight line that is going downwards. So both IDs are right, but maybe one of those two IDs will resonate more with you. So then, just as before, the equation of our straight line going downwards will be y is equal to negative b over a x minus h plus k, and that will be the asymptote going downwards. And this will be everything you need to know about sketching a hyperbola of this form. Now for exercise number 7, we have that x squared over 9 minus y squared is equal to 1. So in order to get this in the exact same form as our general equation, we'll just have to do some adjustments. Well, we can write down x squared as x minus 0 squared, and 9 we can write down as 3 squared. So now this right here is of the same form as this right there. And now we have that y squared can be written as y minus 0 squared over 1 squared, which is the same as 1, and dividing by 1 doesn't change anything, is equal to 1. So now we know that our center point will be the origin, so 0, 0, and we know that a is equal to 3 and b is equal to 1. So let's make a sketch. We first start by drawing the y and x axis as follows. Our origin is our center point of our box. Now a is 3 and is underneath the x, so we're going to have to go 3 steps in the x direction in both directions, so 1, 2, 3, and 1, 2, 3 to the left. So this will give us negative 3 and this will give us positive 3, so those will be the ends of our box. And for the steps in the y direction, we'll have to go 1 step up and 1 step down, like this. So this will be 1 and negative 1. So now we can draw our box as follows, like this. So now we can draw our asymptotes like this. So now we have everything to draw our hyperbola, and it will look something like this. So we follow our asymptote like this, then hit the center of the box. So this will be at negative 3, 0, and then follow the asymptote backwards. And then we'll just do the same at the opposite sides, like this. And this will be our sketch for our hyperbola. So now, just for fun, let's calculate the asymptotes. We know that the general formula for asymptote going upward is equal to y is equal to b over a times x minus h plus k, and h and k are 0, so y will be just b over a times x, and b is 1 and a is 3, so our asymptote going upward will be y is equal to 1 over 3 times x, and for our asymptote going downward we just have to add a negative sign in front of the 1 over 3 times x, so this will be y is equal to negative 1 over 3 times x, and this will be our answer for exercise number 7. Now for exercise 8, we have that x minus 1 squared over 9 minus y plus 1 squared over 16 is equal to, well, this should be 1, so is equal to 1. So this looks a lot like our general equation. The only thing that is left to do for us is to write down the 9 as something squared, and 9 can be written down as 3 squared minus y plus 1 squared over 16, and 16 can be written down as 4 squared is equal to 1. So now we have our equation in the general form. So we know that h comma k will be equal to 1 comma negative 1. K is negative 1 because in our equation we have plus 1, and in the general equation it's negative k. So in order to make this negative positive is by making k negative, because negative times something negative is positive. So that's why k is negative 1. And then we have that a is equal to 3 and b is equal to 4. So let's make our sketch. Let's first start by drawing our y-axis like this and our x-axis like this. So the center of our box will be 1 comma negative 1. So 1 will be around here and negative 1 will be around here. So the center of our box will be right over here. So the length of our box in the x direction will be our a constant, because a is underneath the x. So, and because a is 3, we'll have to go 3 to the right and 3 to the left. So 1, 2, 3 to the right and 1, 2, 3 to the left. Now for our length of our box in the direction of y, we'll have to go 4 up, because b is 4 and b is underneath the y, so we'll have to go 4 up. So 1, 2, 3, 4, and 4 down, 1, 2, 3, 4. And now we can draw our box like so, and now we can draw our asymptotes by connecting the corners like this. And now we have everything in order to sketch our hyperbola properly. So the only thing we have to do is follow our asymptote, hit the center of our side of our box, and then follow our asymptote like this, and the same for the opposite side. So follow the asymptote, hit the box in the middle, and then just follow our asymptote backwards like this, and this will be our sketch. And once again, if you want to know what our asymptotes are, well, we know that the equation is b over a, which is 4 over 3 times x minus h, which is 1, plus k, which is negative 1. And this will be the equation for the upward line, and then this will be the equation for the downward line. So just add a negative sign in front of our slope, and this will be the equation for our asymptote going downwards, and this at its whole will be our answer for number 8. The last general equation we're going to look at is another hyperbola, but this time of the form y minus k squared over a squared minus x minus h squared over b squared is equal to 1. So this time it will look something like this. And one way to remember whether it's this form or this form, well, look at the first term. It's in term of y, as you can see right over here. Well, when the first term is in terms of y, then it will be along the y-axis, so we'll have this form. And when you have the form right over here, the first term is in terms of x, so then it will be along the x-axis. So this is the x-axis, so it will be something like this. So that's one way to remember it. Now, how to sketch it? Well, it's just the same procedure as before. So the center point of the box is still h, k for x and y coordinates. So let's draw a point right over here, which is h, and here it's k. So now we have to find the length of the box. So right over here we have that a is underneath the y. That means we have to go a steps in the y direction. So let's do that. So let's say in this case that a is equal to 3, so 1, 2, 3, which is the same as a, so 1, 2, and a, going in the y direction, and then going a steps in the opposite direction, so 1, 2, and a. And this will be the ends of our box in the y direction. And for our b constant, we have that b is underneath the x, so the length of the box will be in the x direction. So we'll have to go b steps in the x directions to both sides. So let's say that b is in this case 2 steps, so 1 b steps to the right and 1 b steps to the left. So now we have everything to draw our box, so let's do that like this. And now we're going to have to connect the corners for the asymptote, so let's do that. And now that we have our asymptotes, the only thing that is left to do is to sketch our hyperbola, which will be of the form along the y-axis, because the y term in our equation is in front. So let's do that. So let's follow the y asymptote, hit the box in the middle, and then go back following the y asymptote, and now repeat the procedure for the opposite side. So we're following the asymptote, hitting the box in the middle, and then going back following the asymptote like this. And this will be the sketch of our hyperbola of this form. So now let's find the actual equations of our asymptote lines. So just as before, our point slope equation is equal to y is equal to our slope times x minus a random x coordinate plus y coordinate that satisfies our equation. So our slope is equal to the change in y over the change in x, and we know that this right here is equal to b, and this length is equal to a. So the change in y will this time be a, and the change in x will this time be b. So our equation becomes y is equal to a over b times x minus x1 plus y1. And once again, with x1 and y1, we know that one point that satisfies this equation is the point h, k, so the center point of our box. So y will become a over b times x minus h plus k. So this will be our equation for the upward asymptote, and y is equal to negative a over b times x minus h plus k will be our equation for our asymptote going downwards. And this will be everything you need to know in order to sketch a hyperbola of this form. Now for exercise 9, we have that y squared over 16 minus x squared over 9 is equal to 1. So let's do some operations so that we'll get this equation in the same form as our general equation. So let's say that y squared is the same as y minus 0 squared over 16, which is the same as 4 squared, minus, well, x squared is the same as x minus 0 squared over 9, which can be rewritten as 3 squared is equal to 1. So now we know that our h, k coordinate is the same as our origin 0.0, and that our a coefficient in this case is 4 and our b coefficient in this case is 3. So let's try to sketch this. Well, let's first start by drawing our x and y axis like this. The origin is just right over here, so this will be the central point of our box. And now we'll have to look. Our a coefficient is underneath the y, so we'll have to go a steps in the y direction, and because a is equal to 4, we'll have to go 4 steps in the y direction. So 1, 2, 3, 4 going up, and 1, 2, 3, 4 going down. So this will be 4 and this will be negative 4. And now for b coefficient, well, this is underneath the x term, so we'll have to go 3 steps to the right, so 3 steps in the x direction to the left and to the right. So 1, 2, 3 steps to the right, and 1, 2, 3 steps to the left. So this will be -3 and this will be +3. So now let's draw our box like so, and now let's connect the corners to get our asymptotes like so. And now the only thing that is left to do is to actually sketch the hyperbola. So because the leading term is in terms of y, we know that this is the second form of our hyperbola, which is along the y-axis, so it will look something like this. So let's sketch this. So first we're going to follow our asymptote, hit the box in the middle, and then go back following our asymptote like this. And now let's do the same, but on the opposite side. So let's follow our asymptote, hit the box in the middle, and then go all the way back following the asymptote like so. So now the only thing that is left to do is to actually find our asymptotes. Well, the general equation is y is equal to a over b times x minus x1 plus y1 for the upward asymptote. And because x1 and y1 can be either point that satisfies our asymptote going upward, well, let's take the center point, which is 0, 0. So x1 and y1 will become 0, and we'll get that y is equal to a over b, which is 3 over 4 times x. And the asymptote going downwards will be y is equal to -3 over 4 times x. So just add a negative sign in front of the 3 over 4x, and this will be our full solution. For the last exercise, we have that y plus 1 squared over 4 minus x minus 2 squared is equal to 1. So let's get this in our general form. So we have y plus 1 squared over 4, which can be rewritten as 2 squared minus x minus 2 squared over 1 squared, because dividing by 1 doesn't change anything, is equal to 1. So now we know that our center point of our box, which is hk, is equal to 2, -1. The 1 is negative because in our equation we have a positive 1, and in the general equation it's -1. So in order to get this negative sign to be positive, k has to be negative. So that's why k is -1. And for our a coefficient, we have that this is equal to 2, and for our b coefficient this is equal to 1. So let's try to sketch this. Let's draw our x and y axis like so. So the point 2, -1 will be, if this is 1, 2, and this will be -1, so over here will be the center of the box. So now, according to our general formula, a is underneath the y, so we'll have to go a steps in the y direction, and because a in our case is 2, we'll have to go 2 steps up, so 1, 2, and 2 steps down, 1, 2, like so. And for our b coefficient, because it's underneath the x, we'll have to go 1 step to the left and 1 step to the right. So 1 step to the left like this, and 1 step to the right like that. So now let's draw our box like so, and now let's connect the corners to get our asymptotes like so. And now we have everything to draw our hyperbola. Because our leading term is in terms of y, we'll have the hyperbola of the form according to our y-axis, so it will look something like this. And now let's try to draw this. So we follow our asymptote like this, hit the box in the middle, and then follow our asymptote back. And now let's do the same for the opposite side. We follow our asymptote, hit the box in the middle, and then follow our asymptote all the way back. And this will be our sketch for our hyperbola. But now let's calculate the asymptotes. So the general formula is y is equal to a over b times x minus h plus k for the upward asymptote. So this right here will be equal to a over b, which is the same as 2 over 1. So 2 times x minus h, which is just minus 2, plus k, and k is -1, so this will be -1. And for our downward asymptote, we'll just have to put a negative sign in front of our equation, and we'll get that y is equal to -2 times x minus 2 minus 1. And this will be the equation for the asymptote going downwards. And this will be the full answer of our last exercise.